Geosynchronous Satellite Launch Vehicle, GSLV. Geosynchronous Satellite Launch Vehicle, GSLV, is a class of expendable launch systems, or expendable launch vehicles, ELVs, operated by the Indian Space Research Organisation, ISRO. GSLV has been used in 18 launches since 2001. The Geosynchronous Satellite Launch Vehicle, GSLV, project was initiated in 1990 with the objective of acquiring an Indian launch capability for geosynchronous satellites. GSLV uses major components that are already proven in the Polar Satellite Launch Vehicle, PSLV, launch vehicles in the form of the S-125 S-139 solid rocket booster and the liquid-fueled Vickers engine. Due to the thrust required for injecting the satellite in a geostationary transfer orbit, GTO, the third stage was to be powered by a liquid oxygen, sometimes abbreviated as LOX or Loxygen and liquid hydrogen, LH2, cryogenic engine which at that time India did not possess or have the technological expertise to build. The aerodynamic characterization research was conducted at the National Aerospace Laboratories, NAL, 1.2 meter, 3.9 foot, trisonic wind tunnel facility. The first development flight of the GSLV, Mark I configuration, was launched on April 18, 2001 was a failure as the payload failed to reach the intended orbit parameters. So, the launcher was declared operational after the second development flight successfully launched the GS-82 satellite. During the initial years from the initial launch to 2014 the launcher had a checkered history with only 2 successful launches out of 7, resulting in the rocket gaining the nickname Naughty Boy. The third stage was to be procured from Russian company Glavkosmos, including transfer of technology and design details of the engine based on an agreement signed in 1991. Russia backed out of the deal after United States objected to the deal as in violation of the Missile Technology Control Regime, MTCR, in May 1992. As a result, ISRO initiated the Cryogenic Upper Stage Project, CUSP, in April 1994 and began developing its own cryogenic engine. A new agreement was signed with Russia for 7 KVD-1 cryogenic stages and 1 ground mock-up stage with no technology transfer, instead of 5 cryogenic stages along with the technology and design as per the earlier agreement. These engines were used for the initial flights and were named GSLV Mark I. The 49 meters, 161 feet, tall GSLV, with a liftoff mass of 415 metric tons, 408 long tons, 457 short tons, is a 3-stage vehicle with solid, liquid, and cryogenic stages respectively. The payload fairing, which is 7.8 meters, 26 feet, long and 3.4 meters, 11 feet, in diameter, protects the vehicle electronics and the spacecraft during its ascent through the atmosphere. Fairing is discarded when the vehicle reaches an altitude of about 115 kilometers, 71 miles. GSLV employs S-band telemetry and C-band transponders for enabling vehicle performance monitoring, tracking, range safety, flight safety and preliminary orbit determination. Next, the Redundant Strap-Down Inertial Navigation System, or SINS, Inertial Guidance System, IGS, or Inertial Navigation System, INS, of GSLV housed in its equipment bay guides the vehicle from liftoff to spacecraft injection. The digital autopilot and closed-loop guidance scheme ensure the required altitude maneuver and guide injection of the spacecraft to the specified orbit. The GSLV can place approximately 5,000 kilograms, 11,000 pounds, into an easterly low Earth orbit, LEO, or 2,500 kilograms, 5,500 pounds, for the Mark II version, into an 18 degrees geostationary transfer orbit. The first GSLV flight, GSLV D1, used the L40 stage. Subsequent flights of the GSLV used high-pressure engines and the strap-on boosters called the L40H. The GSLV uses 4 L40H liquid strap-on boosters derived from the L37.5 second stage, which are loaded with 42.7 metric tons, 94,100 pounds, of hypergolic propellants, UDMH and N2O4. The propellants are stored in tandem in 2 independent tanks 2.1 meters, 6 feet 11 inches, diameter. The engine is pump-fed and generates 760 kilonewtons, 170,000 pounds force, of maximum thrust, with a burn time of 154 seconds. GSLV D1 used the S-125 stage, which contained 125 metric tons, 123 long tons, 138 short tons, of solid propellant and had a burn time of 100 seconds. All subsequent launches have used enhanced propellant-loaded S-139 stage. The S-139 stage is 2.8 meters, 9 feet 2 inches, in diameter and has a nominal burn time of 100 seconds. The GS2 stage is powered by the Vickers engine. It has a diameter of 2.8 meters, 9 feet 2 inches. The third stage of the GSLV Mark II is propelled by the Indian CE 7.5 cryogenic rocket engine, while the older defunct GSLV Mark I is propelled using a Russian-made KVD-1. It uses liquid hydrogen, LH2, and liquid oxygen, LOX. The Indian cryogenic engine was built at the Liquid Propulsion Systems Center, LPSC. The engine has a default thrust of 75 kilonewtons, 17,000 pounds force, but is capable of a maximum thrust of 93.1 kilonewtons, 20,900 pounds force. In GSLV F-14 mission, a new white-colored C-15 third stage was introduced, which has more environmental-friendly manufacturing processes, better insulation properties and the use of lightweight materials. GSLV rockets using the Russian cryogenic stage, CS, are designated as the GSLV Mark I, while versions using the indigenous cryogenic upper stage, CUS, are designated the GSLV Mark II. All GSLV launches have been conducted from the Satish Dhawan Space Center in Sriharikota. The first developmental flight of GSLV Mark I rocket had 129 metric tons, 264,554.7 pounds, S-125 first stage, and was capable of launching around 1,500 kilograms, 3,307 pounds, into geostationary transfer orbit. The second developmental flight replaced the S-125 stage with S-139. It used the same solid motor with 138 metric tons, 304,237.9 pounds, propellant loading. The chamber pressure in all liquid engines was enhanced, enabling a higher propellant mass and burn time. These improvements allowed GSLV to carry an additional 300 kilograms, 661.4 pounds, of payload. The fourth operational flight of GSLV Mark I, GSLV F-06, had a longer third stage called the C-15 with 15 metric tons, 33,069.3 pounds, propellant loading, and also employed a 4 meters, 13.1 feet, diameter payload fairing. GSLV Mark II variant uses an Indian cryogenic engine, the CE 7.5, and is capable of launching 2,500 kilograms, 5,500 pounds, into geostationary transfer orbit. Previous GSLV vehicles, GSLV Mark I, have used Russian cryogenic engines. For launches from 2018, a 6% increased thrust version of the Vickers engine was developed. It was demonstrated on March 29, 2018 in the GS-86A launch second stage. It will be used for the 4 Vickers engines on the first stage boosters on future missions. A 4-meter, 13.1-foot, diameter ogive payload fairing was developed and deployed for the first time in the EOS-03 satellite launch on August 12, 2021, although this launch was a failure due to technical anomalies with the cryogenic upper stage, CUS. This will allow GSLV vehicles to accommodate larger payloads. As of October 2024, ISRO has stopped selling GSLV Mark II rockets. 8 known launches are planned with NVS missions, Indian Data Relay Satellite System or IDRSS missions, and the NASA ISRO Synthetic Aperture Radar (NISAR) mission. The Reusable Launch Vehicle Technology Demonstration (RLVTD) program is a prototype spaceplane concept created by ISRO. For the Orbital Return Flight Experiment, a modified version of the GSLV Mark II launcher, with the upper cryogenic stage replaced with the PS4 stage from the PSLV, is currently in development, as the RLV won't need all the excess energy produced by the CUS.